Dear students, I am Rakesh Umdi, HOD of Mathematics Department, Jain Polytechnic, Belagavi. In this session, I'll be discussing the second part of vectors, Unit 2. In this second part, I'll be covering area of triangle and parallelogram, angle between the vectors, work done, moment of the force. These all are applications of vectors. First of all, area of triangle and parallelogram. We have the formula for area of triangle as well as the parallelogram, that is area of triangle is half into magnitude of vector A cross vector B. Here vector A and vector B are two adjacent sides. Area of parallelogram is vector A, magnitude of vector A cross vector B. That's it. Now we'll understand this using some examples. I have here one example. Find the area of parallelogram whose adjacent sides are 3i plus 2j minus k and I plus 2j plus 3k. Here they are given two adjacent sides. Let's take these two adjacent sides as vector A and vector B. Now, as the area of parallelogram says, we have to find out magnitude of vector A cross vector B. So first of all, I'll find out vector A cross vector B. That is, vector A cross vector B is determinant of the first row should be I, j, k. Second row should be coefficients of I, j, k in the vector A, that is 3, 2, minus 1. I have taken here. And the third row should be the coefficients of I, j, k in the vector B, 1, 2, 3. Now we all know how to solve the determinant of order 3 by 3. That is I into 2 3s are 6 minus 2 minus 1s are minus 1 minus 2. So it will be plus 2. 6 plus 2 is 8i. J into minus j into 3 3s are 9 minus 1 minus 1s are minus 1. It will become plus 1. Plus k into 3 2s are 6 minus 1 2s are 2. 8i minus 10j plus 4k will be vector A cross vector B. The magnitude of vector A cross vector B will be is equals to square root of 8 square plus minus 10 square plus 4 square. 8 square is 64, 10 square is 100, 4 square is 16. If I add these all three quantities, then I'll get 180. That is, area of parallelogram is square root of 180 square units. Now next, we'll see one example for area of triangle. Find the area of triangle whose adjacent sides are 2i plus j minus 4k and 3i plus j plus k. Again they have given two adjacent sides. Let's take this as vector A and this one as vector B. Vector A cross vector B will be is equals to determinant of first row ijk, second row coefficients of ijk in the vector A 2, 1, minus 4, and the third row should be the coefficients of ijk in the vector B, that is 3, 1, 1. Now I'll expand this determinant along the first row. I into 1 minus 4s are minus 4, hence it will become plus 4, minus j into 2 1s are 2, minus 3 minus 4s are minus 12, hence it will become plus 12, plus k into 2 1s are 2, minus 3 1s are 3. 1 plus 4 is 5i, minus 2 plus 12 is 14j, 2 minus 3 is minus 1 into k is minus k. Now we have to find out the magnitude of this. Magnitude of vector A cross vector B will be equal to square root of 5 square plus minus 14 square plus minus 1 square. That is 5 square is 25. minus 14 square is 196 and plus minus 1 square is 1. Add all the quantities, then I'll get square root of 222. This is just magnitude of vector A cross vector B. But area of triangle is half into magnitude of vector A cross vector B. If I find only this much, this will be the area of parallelogram. But we need to find out now area of triangle. So half into magnitude of vector A cross vector B. That is magnitude of vector A cross vector B is square root of 222 divided by 2 square units is the area of the triangle. Now we'll move on to the next part, that is angle between two vectors. Now we have here two formulas which gives us angle between two vectors. First one is cosine of angle between the two vectors, that is cos theta is equals to vector A dot vector B divided by magnitude of vector A into magnitude of vector B. And the sine of angle between the two vectors is sin theta is equals to magnitude of vector A cross vector B divided by magnitude of vector A into magnitude of vector B. Now let's understand this concept using some examples. For example, find cosine of angle between vectors 4i minus 2j plus 5k and 2i minus 3j plus 4k. The answer is, first of all we have to consider the given two vectors as vector A and vector B. Now they asked to find out here cosine of angle, so I have to use the first formula. Cos theta is equals to vector A dot vector B divided by magnitude of vector A into magnitude of vector B. Now we have to find out first vector A dot vector B, then magnitude of vector A, afterwards magnitude of vector B. And after finding these all values, we have to substitute into this formula. First, vector A dot vector B is equals to vector A dot vector B. I have written here. Now we have to find out the dot product between the two vectors. So we have to multiply just numbers as well as the signs. 4 2s are 8, minus into minus plus. 2 3s are 6, plus into plus plus. 5 4s are 20. Add these all three, you will get 34. This is dot product between two vectors. Magnitude of vector A, that is under root coefficients of I, j, k in the vector A. 4 square plus minus 2 square plus 5 square. 4 square is 16, minus 2 square is 4 and the 5 square is 25. Add all this, you will get root of 45. This is magnitude of vector A. Magnitude of vector B. Now magnitude of vector B is equal to square root of 2 square plus minus 3 square plus 4 square. 2 square is 4, minus 3 square is 9 and the 4 square is 16. Add all these three, you will get root 29. Now cos theta is equals to vector A dot vector B is 34 divided by magnitude of vector A is root 45 into magnitude of vector B is root 29. This is the cosine of angle between two vectors. We have one more example here. Find sine of angle between the two vectors 2i minus j plus 3k and I minus 2j plus 2k. Here again they are given two vectors. Let's consider these two vectors as vector A and vector B. Now sin theta is equals to magnitude of vector A cross vector B divided by magnitude of vector A into magnitude of vector B. First of all, we will find out vector A cross vector B as well as its magnitude, then magnitude of vector A, and then magnitude of vector B. Vector A cross vector B is equals to determinant of first row should be ijk, second row the coefficients of ijk in the vector A, that is 2, -1, 3. Third row should be the coefficients of ijk in the vector B, that is 1, -2 and 2. Now we know how to solve this. We have to expand this using the first row, I into -1 2s are -2 minus -2 3s are -6, hence it will become +6, minus j into 2 2s are 4 minus 1 3s are 3, plus k into 2 2s are 4 minus 4, 2 into -2s are -4, minus 1 minus 1s are -1, hence it will become +1. Now vector A into vector A cross vector B is equals to 6 minus 2 is 4i minus 4 minus 3 is 1 minus 1j, minus 4 plus 1 is -3, minus 3 into k is -3k. Now I have to find out the magnitude of this. Magnitude of vector A cross vector B is equals to square root of 4 square plus -1 square plus -3 square, that is 4 square is 16, -1 square is 1, -3 square is +9. Now adding these all three quantities, I'll get root 26 is the magnitude of vector A cross vector B. And then magnitude of vector A, that is square root of 2 square plus -1 square plus 3 square, that is 2 square is 4, -1 square is +1, 3 square is 9. 9 plus 1 plus 4 will be root 14. Magnitude of vector B will be is equals to under root 1 square plus -2 square plus 2 square. 1 square is 1, 2 square is -2 square is +4, 2 square is 4. 4 plus 4 plus 1 is root 9, that is square root of 9 is 3. Now I'll substitute the values of vector A cross vector B, magnitude of vector A cross vector B as well as magnitude of vector A vector B in the formula, that is sin theta is equals to magnitude of vector A cross vector B is root 26 divided by magnitude of vector A is root 14 into magnitude of vector B is 3. This is the sine of angle between two vectors. Now we'll move on to the next concept, that is work done and magnitude of the moment of the force. To find out work done as well as magnitude of moment of the force, we have here formula, that is work done is equals to force into displacement. This is dot product. Magnitude of moment of force is magnitude of displacement into force, that is cross product. Now let's understand this concept using some examples. Find the work done by the force F vector is equal to 5y plus 3j plus 7k in moving a particle from the point A 1 2 minus 1 to the point B 3 1 minus 4. Now answer. Now what they are given? They are given the force F vector, that is 5y plus 3j plus 7k, and we have to find out the displacement using these 2 points. First of all, convert these 2 points in the form of vector. I want the distance between A and B, that is AB. AB will be is equals to OB minus OA. OB minus OA will give us the distance between A and B. AB vector is equals to OB. OB is 3i plus 1j minus 4k minus OA 1i plus 2j minus 1k. Now open the brackets. 3i minus 1i is 2i. J minus 2j is minus j. Minus 4k plus k is minus 3k. This is the displacement. Work done is equals to force into displacement, that is dot product. It is also denoted by S vector. We can denote it by D vector also, no problem. F vector is given force 5i plus 3j plus 7k dot S vector is 2i minus j minus 3k. 5 2s are 10, plus into minus minus, 3 1s are 3, plus into minus minus, 7 3s are 21. Now 10 minus 3 minus 21 will be minus 14 units will be the work done. Here one more example we have. A force F vector is equals to 2i plus j plus k is acting at a point minus 3 2 1. Find the magnitude of moment of the force F vector about the point 2 1 2. Now they are given here force F vector 2i plus j plus k. We have to find out the displacement. Displacement is AB vector minus OB minus OA. We know this. In the previous example we have done this. OB is 2i plus j plus k minus OA is OB is 2i plus 1j plus 2k minus OA is this point minus 3i plus 2j plus 1k. Now open the bracket. 2i j 2k minus into minus plus 3i minus 2j minus k. 2i plus 3i is 5i plus j minus 2j is minus j. 2k minus k is plus k. Moment of the force is equals to r vector cross f vector. R vector cross f vector is equals to r is just a displacement. We can denote that d by r also. To differentiate, I have written here r. As it is a cross product, we have to take the determinant of I, j, k, and the second row should be the coefficients of I, j, k in the vector force. The distance, it is displacement 5i minus 1 plus 1. And the third row should be coefficients of I, j, k in the force, that is 2 1 1. Now I into minus 1 minus 1 minus j into 5 1s are 5 minus 2 1s are 2, k into 5 1s are 5 minus 2 minus 1s are minus 2, hence it will become plus 2. Now I got minus 2i minus 3j plus 7k. Now we have to find out the magnitude of vector A, vector r cross f vector, that is square root of minus 2 square plus minus 3 square plus 7 square. Minus 2 square is 4, minus 3 square is 9, 7 square is 49. If you add these all three quantities, I'll get root 62.